Alright, so in the last video you learned about what an inverse is and how to solve it, or how to find one. And this is just going to be a little bit more practice. So I've written down the steps that the video told you from the last video. You need to just find these, like copy them down if you don't have them somewhere already in your notes. But we're going to use these steps really to solve all of these different functions and find their inverse. So let's use this to start with the first one here. So find the inverse of f of x equals 1/2 x minus 4. So step one is that we need to set this equal to y. So we're going to talk about the end should be something like this, f of negative 1 of x. That should be what we have at the end, but right now we're going to change this to a y. And then we're going to, step 2, solve for x. So all I'm going to do is try to isolate or solve for here. So this x here needs to be the thing that is alone. So I'm going to do my steps to get there. So first thing I'm going to do is just add 4 to both sides, just like if I was solving anything else. So now I have y plus 4. I cannot make that 4y because those are not like terms. Equals 1/2 x. Okay, to get rid of a 1/2, I can do two things. I can multiply by 2 on both sides, or I can multiply by the reciprocal, 2 over 1, to always get rid of a fraction. So I'm just going to multiply by 2 over 1, because the 2 and the 1 cancel out. I'm going to do the same thing here, times 2 over, well, it's not going to work out, times 2 over 1. Now, 2 over 1 is really just 2, so you can write that as 2 times y plus 4 equals, now x is alone. And then I want to distribute that 2 to both the y and the 4, so my final answer is 2y plus 8 equals x. Okay, so I did step 1, set equal to y. I did step 2, solve for x. And now I just need to switch x and y back. So I'm going to, over here, switch x and y. So where x was, I'm going to put y. And where y was, I'm going to put x. So 2x plus 8. So now this is the inverse function we've got. So then the inverse of the example 1 is 2x plus 8. And we just write that in a different way. So instead of y equals, and we could always switch this so that we know we're more used to this form here, y equals 2x plus 8, but instead we're going to show that y is actually the inverse of the original function f of x. So to show that it's the inverse, we just write this notation. F of negative 1, the inverse of f of x, is 2x plus 8. And then we're done. That's the inverse. So that means that this function here, 2x plus 8, if we were going to make a table of x and y values for both the regular and the inverse, right? If I was going to make a table here for this function, 1/2 x minus 4, I'd get, if I plugged in 0 to the original equation here, 1/2 times 0 is 0, and then negative 4 would be my y value. Now if I plugged in negative 4 as my x here in my inverse, I should get 0. That's the whole point. It goes from x to y and then y to x. It's the inverse. So it's saying, hey, if I plugged in the y as the x, I should get the opposite. So let's test that. If I plug in negative 4 as the x, that would be 2 times negative 4 plus 8. Well, 2 times negative 4 is negative 8. And negative 8 plus 8 is 0. So that is the inverse. Okay? Let's try another example. This is again still linear. So we're going to use our steps. We're going to set this equal to y. Then we're going to solve for the x here by isolating. So I'm going to subtract 6. Y minus 6 equals 3x. And then to get rid of this 3, I'm going to divide by 3 on both sides. Here cancels, and I have x equal to this whole deal. So I could write this a few ways. I could write this as y minus 6 over 3, or I could split it and say, well, this is really y divided by 3 minus 6 divided by 3, and simplify from there. Well, y divided by 3, you can leave it as that, or I can write it as 1/3 y. And then minus, well, 6 divided by 3 is 2. So there's a lot of ways I could write this. It really doesn't matter. But all I need to know now is that I have to switch it. So I'm going to go with this one here, but you could totally go with this one here. It doesn't really matter. So if this is equal to x, I have x equals, I'm going to switch the order so that I like to look at it where the isolated variable is on the left. X equals 1/3 y minus 2. Now that was our first step. First 2 steps are done. Set equal to y, solve for x. Now we need to switch x and y back and then change the notation. So I'm just going to literally switch these 2 variables. So y equals 1/3 x minus 2. And then I'm going to say, well, this isn't actually just y. It's the inverse of the original function here. It's the inverse of f of x. So to show it's the inverse, I write it like that instead. Done. Okay. Now, those are 2 linear examples. I want to make sure that we could do this with a quadratic or a rational or a square root function as well. So let's try this next example. This is a quadratic. Let's find the inverse of f of x equals x minus 3 squared minus 5. Well, first things first, let's set it equal to y. And I just need to now solve for x. So there's a few things in my way. This -5, this squared, and this -3. I'm going to start first by getting rid of the -5. So y plus 5 on both sides, that goes away. So y plus 5 equals x minus 3 squared. Now, I cannot get rid of that -3 yet until I get rid of that squared. So we know that the inverse of a squared is a square root. So we are going to square root both sides. So this cancels out. Now I just have x minus 3 over here is the square root of y plus 5. I don't know what that is, so I'm going to leave it. All I have to do now to solve is add 3. Now I've got x equals the square root of y plus 5, and then plus 3 on the outside of the radical. Okay, I'm almost done. All I need to do now is switch x and y. So instead of x equals, y equals. And then I'm going to write it in inverse notation. I'm also going to switch the sides because I like to read it left to right. So the inverse of the original function is the square root of x plus 5 plus 3. Done. And one final example with a rational function. Now, I see here g of x. It does not matter that it's g of x versus f of x versus h of x. I'm still going to do the exact same thing. So I'm going to start by writing, instead of g, y equals. And then I'm going to try to solve for x. Well, in this case, x is here twice. So this might be a problem. These are the types of questions that show up on the SAT a lot, so I just wanted to make sure that we addressed it. Now, okay, if I wanted to try to solve for x, the first thing I maybe would want to do is multiply both sides by x plus 5. Multiply both sides by the denominator, so they would cancel out on the right. Now, if I multiply it on the right, I need to multiply it on the left. I don't have room here, so I'm going to write it up top. So right now I have y times x plus 5 equals x minus 3. I'm trying to get x by itself, so I'm not sure how I'm going to get there. I do know that I could distribute, I could distribute the y if I wanted to, and say, well, y times x plus 5y equals x minus 3. I don't know if that helps me, but I'm going to try. Okay, if I know if I have to solve for x's, I need all the x's to be on one side. Now, granted, this is one term here, y times x, but maybe I should just try at least to get all the x's by themselves together. So I'm going to try to put all of the x's on the left and then everything else on the right. That's not the only way to do it, but I'm just going to make all the x's on one side. So if that's true, I need to subtract x here and here. So I'm going to get y x minus x plus 5y equals negative 3. So I just subtracted x on both sides. Negative 3 remains here. None of these are like terms, so I just wrote all 3. Now I've got this 5y that I need to move to the other side by subtracting. So now I have yx minus x equals negative 5y minus 3, or negative 3 minus 5y. Okay, so I still have x's in this weird spot, but now I see the great news is that these two terms here both have x in common. So they have a factor, a common factor of x. So I can actually factor it out and say, well, if I took x out, this is y minus 1, right? Because if I went back and distributed that, that'd be xy minus x, and that's what I want up here. So now I can just divide this part away. Divide the y minus 1 away on both sides. Y minus 1 over y minus 1 cancels. So now I have x by itself is equal to negative 5y minus 3, all divided by y minus 1. I'm almost done. I've solved, but now I need to switch my x's and my y's. So now I'm going to write y where the x is and x where the y was. This shows up twice, still means I just switch it twice. The only thing left I have to do is say, well, hey, this isn't just y equals. This was the inverse of the original function way up here. And the inverse was g of x. So g inverse of x is negative 5x minus 3 over x minus 1. And that is my inverse. Now this third or fourth example was definitely the hardest one, and it's not going to be something that we work a ton on, but it is really, really important for the SAT. So if you need to do more examples of that or you want extra help from me for this because the SAT brings it up a lot, please just go ahead and ask me for that. Otherwise, you should just remember those basic 4 steps on how to find inverses, and then we'll discuss this when we get back from break.